In this video, we're talking about compound types. The first one that I want to discuss is a tuple. So a tuple is a sequence that can contain arbitrary objects. So integers, floats, booleans, strings, none, or even other tuples. So this is a sequence containing anything. I guess not anything, but containing other objects. Tuples are comma separated, and we use parentheses in order to let the user know that it's a tuple. So this is an example of a tuple. X equals 7, negative 7.8, and blue. Okay. Today's video is sponsored by Brilliant. Brilliant is this awesome platform that allows you to learn via interactive questions and puzzles. They have different subjects such as computer science, math, and science. Best of all, it's totally free to get started. All you have to do is go to brilliant.org/KylieYing. And the first 200 people to subscribe will get 20% off an annual premium subscription. And actually on tuples, we can perform a lot of the same operations that we could perform on strings. So for example, we can index this. If I take x1, remember that this is 0, 1, and 2, I would get negative 7.8. And I can even concatenate tuples. So if I do x plus another one, 1, 2, 3, then this would actually give us 7, negative 7.8, blue. Oops. 1, 2, 3. So basically joining the tuple together, just like how we were able to join strings together. We can compare tuples. So does x double equal sign 7, negative 7.8, blue? And this would be true. And we can also loop over these elements, just like how we saw in the sequence. So in my virtual computer world, I'm going to draw this tuple like this. I'm going to use rounded borders to denote that it's a tuple. And then I have 7, negative 7.8, and blue. Okay, and what happens in each of these operations? So when I take the index at 1, it's saying, remember we're labeling these 0, 1, 2, so it's saying go to whatever is at the first index, which happens to be 7.8, and return that. Now, what happens when I add? What this is doing is saying, okay, what is x? X is this 7, negative 7.8, blue. So now I'm going to make this mega tuple with this one attached to it. So 7, negative 7.8, blue, 1, 2, 3. Right? And I didn't assign this to any variable, so I don't have, a variable here. But this here is this solution here. All right. And then also when you're checking for booleans, this is just checking, it's going to x and saying, okay, does this match this? All right. So that is a tuple. Now the next type is a list. So a list is actually also a sequence of other objects. And it is also comma separated. The difference between a list and a tuple is that lists are mutable. Okay, we're going to talk about what that means, so don't worry. But that is the big difference that I want to drill into you. And on the screen, we can tell that a list is a list because it has square brackets. So x equals 1, 5, and none, or something. Okay, so in our virtual computer world, let's draw that out. I have x, and I'm going to put this in square brackets. And I don't want to get this confused with strings, okay? Strings are not lists. Strings are just sequences of characters, okay? But we're going to make sure that we know this is a list by drawing an L up here for a list, okay? So this is 1, 5, and none. Okay, so let me emphasize to you that lists are mutable, okay? And tuples are not. What that means is that if I wanted to come over here and literally just expand the list and add something new here, I could. But in a tuple, I'm not allowed to do that. In a tuple, I would have to redefine x as being x plus that tuple. So -3, and I need this comma to denote that it's a tuple. So I would need to do something like this. And this operation is saying, okay, take what's in x, copy that, and add something to the end of it. So 7, -7.8, blue, and then -3. Okay, and now we're going to reassign this to x. And now this thing, the old x, doesn't exist anymore. All right. Do you see the difference between mutable and non-mutable? With mutable, we can say, okay, remove this, and that's it. Or add a little box. Or, you know, we could come in here and we could say, okay, instead of 5, this is now 2. So actually, instead of this L, I'm going to just denote this with an open top. Because right now, we're going to allow the user to change this. We're going to say, okay, take this 5 out and put this 2 in. All right, so bam. Or we can say, all right, take this none out of the box and we're going to put high in. And that's all okay because this is mutable. With a tuple, you would have to create a new tuple because this tuple is closed. We can't access anything in that box, right? We would have to just create a new one and pull the pieces so we can index from the tuple, but we would have to create a new tuple. That is the difference between mutable and non-mutable. Mutable means you can mutate it, you can change it after it's been created. Now, let me explain that further using some code. So if I do my tuple, and I set this equal to 1, 2, 3, and I have my list, and I set that equal to 1, 2, 3, print my tuple, you know, the 0th item, and I'm also going to print that from my list, and these should be identical, right? Because they should both be 1. Let me run this, and we both get 1. Okay, great. Well, in a list, so if I wanted to change the first item in that to, let's say, 5, I can do that. So let me print out my list here, okay? And I print that, run it, print it. You'll see that we've changed this 1 to a 5. All right, but if I do that for a tuple, this would break. So let's run this. And we get this scary error. So we're not going to do that. Okay, something else that we can do is, as you saw, we did my list dot, we can add something to the end. So if we do append, then that's telling us, okay, we can add something. So now my tuple, or my list, is 1, 2, 3, 4. If I did this with my tuple, you'll see again that we get a big scary error. So we don't want to do that. And it doesn't just have to be like, you know, a number. We can append sky, and that's okay. Something else that we can do is we can actually extend our list with another list. So here, if I do, you know, 5, 6, 7, what this is doing, it's taking my list and it's saying, okay, add on the values in this list. So basically mutate whatever is here and add more boxes, more bins for these few items. So this should be 1, 2, 3, 5, 6, 7 now. Okay, and then we can also actually do something called a pop, which removes the last item. So now it should just be 1, 2. I do want to show you guys what that would look like on the iPad. Basically, what we were doing, so let me write the code in green, maybe I'll use this shade. So when I did x0 equals something, so let's say hi, and let's, for the sake of this example, go back to this here, okay? So 1, 5, and none. Okay, when I do this, it's like setting, kind of like setting a variable. I go to x, I say, okay, give me the 0th index. So remember, this is 1, 2, 0, 1, 2. And I'm gonna say, okay, now set that equal to high. So I'm removing this, I'm taking it out of the bin, and then into the bin, I'm gonna put high. All right. Now, when I append, so if I do x.append, and let's just append 2, what that's doing is saying, okay, draw another bin. So this is 3, and then put 2 in that bin, okay? Whatever is in here goes into this bin. Now, I could also do x.extend, oops, if I can spell that right, extend by a list. So I'm going to do 1, 2. And what that's doing, so what this line here, what that's doing is saying, okay, extend, and then put whatever is in this list into here. So put 1 there and 1 there, all right? And then finally, so I'm not doing these sequentially. It's every single time I erase this, it's like as if we erase these commands. But at the very end, we have x.pop. And what this is doing is saying, okay, just get rid of the last box. So I'm coming here and I'm saying, all right, get rid of this entire box, but now I have to draw this thing again because I did not draw the individual boxes. So x.pop removes the last bin. So now my string is just high and 5. High 5. I actually didn't do that intentionally. All right, that is mutability. That is one of the most difficult concepts, I think, for a beginner to grasp in Python. So if you understood this, that is awesome. And if you didn't, don't worry. Just try to get a feel of what you can do with tuples versus lists. And it will come with time, I promise. The next compound object that I wanted to talk about is a dictionary. And this provides a mapping between a key and a value. Let's use a physical dictionary to understand this concept. We opened an English to French dictionary, okay? And assume you only know English. Well, how do you say hello? You would go to hello, where that word is, and then you would look for the value for that key. So hello here is a key, and then whatever the French word is the value. Okay, so the value in this case would be bonjour. You know, in my dictionary, I have to go and find hello, and then this gets mapped to bonjour, right? So this here in green, this is going to be my key, and this here in purple is going to be my value. Similarly, I might have goodbye and au revoir. Okay, so this is the value to this key. In Python, we're actually providing a tool to do something very similar. So what I can do, let's erase this, is I can actually define a dictionary called English to French. And dictionaries are defined with these curly brackets. Okay, and I can put a key value mapping into this dictionary. So I can say hello, and I can make this equal to bonjour. All right, so now if we print English to French, you'll see that this is, if I can spell this right, you'll see that it has hello mapped with a colon to bonjour. So let me write this down on the iPad. A dictionary is something like this. So dictionaries, we denote this with curly brackets, and then inside the curly brackets, we have the key value pairs. So we have hello, map to, so the colon is for the mapping, and then bonjour, just like as you see here. And we can actually define a dictionary this way as well. So here, if I print this, you'll see that we get the same thing, and that's valid. Okay? And what we can actually do is we can retrieve this value if we try to index for hello. So if I print this, then we get bonjour. Now, instead, let's see what happens if I put goodbye in here. So if I put goodbye, then this goes au revoir. And I can still get hello. But now I can also get goodbye. Okay. What do you think would happen if I tried to look something up by a value? Think about if I were trying to look bonjour up in the English to French dictionary. Would I get anything? So no, right? There's this big red error, and this is not good. It only works when we look up the keys, okay? Let's draw this out. So if I go to my virtual computer world, and I have English to French, and I am putting this into a dictionary. So how I like to convey dictionaries is I like to think about this as kind of a key box almost, okay? I'm going to use the same open bin as I did for lists because dictionaries are also mutable. As you can see, we're changing this dictionary over here. So here, when I put in hello to bonjour, what I'm doing is creating this mapping. So I have hello up here and then bonjour down here. All right. And what we're doing is this top part, these are the keys in the key box. These are our English words. These are the things that we can go and retrieve them by. When I put in goodbye in here, I did not do the spacing well. Oh well. We get au revoir down here. And again, this is our key. So now when we're indexing and when we want to get English to French of hello, what our computer is doing, it's saying, okay, go into the virtual computer world, and is there a key labeled with the thing inside the brackets? Is there a key with hello? Yes, there is. So now return that value, right? So this here would give us bonjour. And now dictionaries, for the keys, for these things, you can have arbitrary objects. You can have 1, 2, 3. You could have true, false. It doesn't really matter, but there is one little caveat. So it needs something immutable as the key. And can you think of a reason why that might be? So let's think about a physical door key that, you know, let's say it's made out of gold. That would be pretty nice, but let's say it's made out of gold and you can actually bend it. Well, if you change the key, does it still fit into the door? Like, at what point does the key not become the key anymore, right? And that's exactly the same intuition as to why in Python we need to have an immutable object as the key. And dictionaries also do not have any ordering, okay? Finally, let's talk about sets. Okay, so a set is just kind of a group of objects. But in this group, there's no repeats. Similar to dictionaries, these are denoted with a curly bracket, but instead of pairs, you'll just see individual items. So something like this is a set. All right, let's go on to the computer and see an example. So if I have my set, and actually I'm just gonna set this to an empty set at first. I can put 1 into my set. Okay, so now let's just keep printing my set. So I've created an empty set, I've put 1 into it. So we just have a set with the value 1 inside of it. I'm going to put 2 now inside. And so we have a set with 1 and 2. Well, let's see what actually happens when we put 1 again into the set. I told you that there couldn't be repeats. So what do you think will happen here? We actually get 1 and 2 without repeats. Going back to the iPad, if I go to the virtual computer world and I draw a variable, my set, what I like to point sets as is kind of just like a blob. Okay, and if I have an empty set, it's just an empty blob. So let's copy that code. So my set was equal to a set at first, so empty blob. And then my set dot add 1. That means, okay, is 1 inside this blob? No, so let's put 1 in here. And if I do my set dot add 2, all right, is 2 inside this blob? No, so let's put 2 in there. My set dot add 1, oh, well, 1 is already in here. So we're not actually gonna add that again. And if I do my set dot add 3, okay, well then we add 3. And this is a blob, there's no order to a set. The reason why we would use a set is maybe we can quickly check, if we've already seen a value. So the advantage of a set is that it's really fast to look at what's inside of a set. So if you have a really long Excel document with a ton of repeats, imagine if you just had a collection of everything that you've looked at, and you can just say, hey, have I looked at this? And instantaneously it'll return a value. So that's kind of the intuition behind sets. I'm gonna make a separate video to kind of talk about when to use what. I know that that's a question that a lot of beginners have, so make sure you check out that video. Notes are in the description below, and please join the Discord channel to learn with other people in the Intro to Python community. I've set that up just so that you guys can learn with each other and make this whole journey a little bit easier. So what do you think would happen here? That is the extent of interactive learning on YouTube, which brings me to today's sponsor, Brilliant. Brilliant is a platform that allows you to learn interactively, so you can learn by doing and not just watching. They have a variety of courses ranging from computer science to math to science, ranging all levels from beginner all the way to advanced. Personally, I've been working my way through a quantum computing course on Brilliant. What I really like about Brilliant is that there are very intuitive explanations with graphics that actually help explain a lot of the concepts. Furthermore, it makes you actually think about these concepts rather than just memorizing them. So if you're anything like me and you really like learning interactively, I highly recommend giving Brilliant a try. It's free to get started, and all you have to do is sign up with the link below. Remember that the first 200 people to subscribe will get 20% off an annual premium subscription. All you have to do is go to brilliant.org/Kylie Ying. So yeah, with that, I will see you guys next time.